Hi students, welcome to the session on linear independence and dependence of vectors, right? So let us start the session. Yes, set of first I define what is the meaning of linear independence and dependence, right? So yes, set of vectors is called linearly independent. Set of vectors is called linearly independent if none of them can be expressed in terms of others, can be expressed in terms of other vectors. Okay. This is what linearly independent means, right? Okay. So we must not, if we are not able to express one vector in terms of other vector, then we can call those two vectors are linearly independent vectors. Right, so this definition is valid only if you have two vectors. For example, if you have a two vector set of vectors v1 v2 where v1 is equal to 2v2, means we can conclude that here one vector v1 is expressed in terms of another vector v2, so they are linearly dependent, right? Otherwise we take some other vector v1 v3 where v1 is -1 5, v3 is 2 4. So if they give like this, then we can say here v1 cannot be expressed in terms of v3, so we can say v1 and v3, this set is a linearly independent set of vectors, right? For two vectors, we can use the definition I have given here. But if the set contains more than two vectors or more than three also we can find, but more than four vectors, then how can we define linearly independence, right? So there we have to use some other definition. And what is the definition is, if let us assume that if a vector Let us assume if a vector is a linear combination of other vectors. For example, assume a vector is a linear combination of other vectors. For example, v5 is equal to c1 v1, c2 v2, c3 v3 plus c4 v4. Right? So this implies I can write zero vector as c1 v1 plus c2 v2 plus c3 v3 plus c4 v4 plus -1 v5. I write like this. Yes, that means if I bring v5 this side, this will become a zero vector. This is very important conclusion. Why it is very important conclusion? Let me tell you. Right. So here you see zero vector is written as zero vector here. Zero vector is right here. Zero vector is written as a linear combination of vector from our set, and in which you see at least one coefficient is non-zero. At least one coefficient is non-zero. What is that coefficient? This coefficient. I don't know about C1, C2, C3, C4, but one coefficient is non-zero. This non-zero coefficient we got because we are writing one vector in terms of other vectors. That means we have written a vector as a linear combination of other vectors. If a vector is linear combination of other vectors, then it indicates linearly dependent. So what is the conclusion we are making from here? If the vectors are linearly dependent, one coefficient must be non-zero. Now I come to the proper definition of linear independent and linear dependent, right? So let us assume let V be a vector space as usual. Let V be a vector space and let V1, V2 up to Vn be the elements of VB. P be the elements of V, right? Then V1 up to Vn are called linearly dependent if there exist numbers C1, C2 up to Cn not all equal to 0, such that what is the thing? C1 V1 plus C2 V2 up to Cn Vn is equal to 0. I don't know, only one, at least one coefficient should be non-zero. There must be one non-zero coefficient. Then only these vectors are called linearly dependent. That's what here we are concluding, right? Not all equal to 0. That means at least one is not equal to 0, right? So that is very, very important. If V1, V2, Vn are called linearly independent, if and only if C1 V1 plus C2 V2 up to Cn Vn is equal to 0, provided all the coefficients are 0. That means for all I is equal to 1 to n. If all the coefficients C1, C2 up to Cn, every coefficient is 0, then only if it is equal to 0, then we can call the vectors are linearly independent, right? So I hope you understand this concept. One of the, at least one coefficient is not equal to 0, then they are called linearly dependent, right? So this is the definition available in book, but why this definition has come? From this idea we can conclude, right? If at least one coefficient is not 0, and then when you write one vector as a combination of other vectors, then we can say it is linearly dependent. If all the coefficients are 0, when we write like this, then the vectors are called linearly dependent vectors, right? Okay. I hope you understand this concept. If you have any doubt, please ask in the comment section. I will clarify. Thank you.